Mm, mm. Okay, I think we're good. All right, here we are. How many questions are on the exam? I usually give about 10 questions. Okay, so most of my exams are 10 questions. There's no heavier emphasis on one section over another, so I weigh them somewhat equally. So we're here. So there's going to be what, 1, 2, 3, 4, 5, 6 sections, I guess. So there should be one question from each and probably 2 from some. So maybe for this particular test, 2 questions for each section approximately. I'm not promising 10 questions, but it's in the neighborhood of 10, maybe 9, maybe 11, something like that. Okay. Okay, a quiz. The quiz is now past due. So this is the way you were expected to do the quiz, okay? So this is the format that you want for that. So you're supposed to replace x with negative x for y-axis symmetry, replace y with negative y for x-axis symmetry, and then you do both for origin symmetry, okay? You didn't need to do a graph. You weren't supposed to do a graph. But some of you gave me a graph and said, okay, there's symmetry or not based on that. Okay, but you weren't supposed to do that primarily. The primary idea was that you did it, I'm trying to move my computer here, that you're supposed to do it by this, replacing x with negative x. You get the same thing. That gives me y-axis symmetry. Replace with y with negative y, x-axis symmetry. And by the way, some of you did this, and you said something like, oh, I do get the same thing, but I need your conclusion. The conclusion is that, yes, I do have y-axis symmetry, or no, I do not have y-axis symmetry. So you need to make some statement like that, okay? And if you do both, replace x with negative x and y with negative y, you get the same thing back, so you have origin symmetry. So this was what was expected of you for this problem. Okay, and then for number 2, y equals absolute value of x. So yeah, for number 1, you have all the symmetries. Number 2, replace x with negative x, you get the same thing back. You have y-axis symmetry. But if you replace y with negative y, you don't get the same thing back. So no x-axis symmetry. And if you do both, you don't get the same equation back, so you have no origin symmetry. So that's what was expected of you for this particular quiz. Okay, again, quizzes are out of 5, and since quizzes are individualized now, so normally I don't have to wait for your team members to submit them. I can just tell you right away after I acknowledge that I've gotten your quiz. I will grade it right then and there how you did on the quiz. So quizzes are out of 5. So we got 5 out of 5, that's full credit on every quiz. And you also get to drop 1 of every 4 quizzes. Every time we have 4 quizzes, you get to drop 1. So if you didn't do well on a quiz or you missed a quiz, it's okay, you can drop 1 out of every 4, which basically means what, 1 per month, since there's about 4 weeks per month. Well, this week we're not having a quiz because this week we're having an exam. But in general, you get to drop 1 quiz per month, I guess is a good way to say it, okay? All right, so that's it for the quiz, and now we're ready to start. So we have 1.7 and 1.8 left. So we are here. Okay, so 1 to 17 odd, 19, 20, 21 to 43 odd. So 2 days for 1.7, 2 days for 1.8, and then the exam on Friday. And again, if you haven't already done so, please look up the announcement I sent on Canvas on how I do exams, my rules and regulations there. Okay, and as I mentioned, I just mentioned quickly, I want you to be able to move your camera back so I can see your hands and your work and your surroundings. I'd ask you not to have a background, you know, like some of you have the Golden Gate Bridge or outer space or, you know, it's all green or something like that. Please have your actual surroundings so I can see your actual surroundings. Now, I know sometimes there's privacy issues and maybe you can't physically move your computer back. I get it, but, you know, like I said, you're more likely for me to call on you because that's where I would suspect, you know, something funny might be going on. So I'm more likely to call you because, you know, it's easier to cheat in that situation, okay? But look at all of that announcement I sent on Canvas, so that's that. Okay, so we're ready to start. I gave you an introduction last time, and now let's get started with some of it. So we're doing 1.7 on lines, okay? So I gave you a rehash last Friday just before the quiz on lines and the equations for lines and so forth. Okay, so again, I try to do at least one from each batch. So the first batch, they give you 2 points, and if they give you 2 points, they want you to come up with the equation of the line. So -2, 1, 2, -4, what is the equation of the line? Now, you don't have to graph these, okay? I did just for fun and to teach you something. So it's easy to plot the point -2, 1, and 2, -4, but you don't have to do this on the exam this Friday. So, but we should all agree, if you have 2 points, that's good enough to determine a line, right? I can see that there's a line. So what is the equation of this line? So the technique is to first find the slope. We use the formula for the slope, right? And then after that, you do the point slope form. Okay, so problem 3, and there's a few others that are like that, like number 1 and number 5. How do you do that? So first, I use the formula for slope, which we know was this. Okay, and again, if you want to, I mean, you shouldn't really need it. And frankly, if we were meeting face to face, I would make you guys memorize it. But since we're under COVID and all the other stuff, I'll let you just write the formula if you've forgotten it. But it's y2 minus y1 equals x2 minus x1. You should be somewhat familiar with that. All right, so I used this as x1, y1, x2, y2, right? And I just subtract. So I go -4 minus 1 over 2 minus a minus 2. Back here, it was -4 minus 1 divided by 2 minus a -2. And that comes out to be -5/4. So the slope of the line is -5/4. And a side note, the negative means it's falling. And if you look at the graph, it is falling. It's going down. As I move from left to right, the graph is going down. Okay, and then you throw into something called the point slope form, which is this. So we talked about that on Friday. Y minus y1 equals m times x minus x1. Okay, so I chose my x1, y1 as -2, 1. You could also pick 2, -4. That would also work. All right, so y minus 1 equals m, which I found to be -5/4, parentheses, x minus x1 is x minus a minus 2. Okay, now we just clean up the algebra. That's like x plus 2, right? So make that x plus 2, distribute. So that's -5/4 x, and then -5/4 times 2. The 2 will cancel the 4, leaving me with a -5/2. And then I add 1 to both sides. Add 1 plus 1 plus 1, right? 2 over 2 is 1, but I want to get a common denominator. So that's going to make that -3/2. So final answer, write it as a function. Y equals f of x equals -5/4 x minus 3/2. And that's the final answer. All right, so you had some problems like that. That's an example. Number 11. Let me show you quickly what they want for something like 11. Okay, so 1 through 7, I showed you 1. They give you 2 points. Find the slope-intercept equation of the line. Okay, now 9 through 15-ish, find the slope and sketch the graph. Okay, so we make it look like y equals mx plus b. So for 11, 3x minus y equals 2. If I add y to both sides and subtract 2, that's what I mean by the arrows. Okay, so you should all know plus y, minus 2, minus 2. I'm not going to write all those steps because you're in pre-calc. Your algebra is very good. Okay, now, if you were in my Algebra 1 class, I wouldn't go that fast. But for you guys, I can. So you want to isolate the y. I think you can say, oh, yeah, plus y here, plus y here. That's what I mean by that arrow. Minus 2 here, minus 2 here. That's what I mean by that arrow. So it ends up looking like that. So y equals mx plus b. Y equals 3x minus 2. Okay, so the slope is 3. The b, the y-intercept, is -2. That's rise over the run. Okay, so how do you graph it? Draw my grid. Okay, and by the way, you might have to graph for me. Just do a freehand grid like this. You don't have to get graph paper. Now, if you want to use graph paper, I don't mind, but don't waste your money. Just do something quick and dirty like I did here. You know how to do that. Just go 1, 2, 3, 4, 5. Same thing that way. Same thing that way. Same thing that way. Right? Okay, so I start with a b of -2. So 1, 2 down, and then my slope is 3. That's like 3 over 1. That's 3 divided by 1. That's rise over the run. So I run 1 unit, and I rise 1, 2, 3. That gives me my second dot, and then just draw it after that. Okay, for number 15, all it says is y equals 2. Okay, you have to remember that if it just says y equals a number, y equals a constant, it's a horizontal line. Automatically, it's a horizontal line with a slope of 0, as you can see. Okay, and a side note, if y equals a number is a horizontal line, do you recall what's x equals a number? X equals a constant is a vertical line. Okay, and again, if you want to write that in your cheat sheet, you may. So y equals 2, horizontal. X equals 2, or x equals 5, or x equals -7. Those are vertical lines. We'll talk more about that today. But anyway, all I do is I go up to y equals 2 and draw myself a horizontal line, and you're done. That's it. Okay, the problem's finished, but I'll just dig deeper. As I walk along this line here, okay, if I keep going back and forth like this, right, notice I'm changing the x value, but everywhere on this line, the y is 2, right? Like this is 1, 2, and this is 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, right? And 0, 2, -1, 2, -2, 2, -3, 2, -4, 2. Way out here somewhere is -82. So everywhere along this line, the x changes, but y is stuck at 2, right? Okay. All right, so that's how to do that one. Okay, 17, there's part A, B, C, D. Find equations of the lines that pass through the point 1, 4, and have the given slope. So all they're doing is changing the slope, but they all go through the point 1, 4. Okay, and I don't remember if I did this, but and let me project for you that. It looks like it's a little bit better. Maybe that's because I have a new computer. I don't know. What page is this? 62. And here's the bottom part, if you need that. Okay, I'm not sure if you got the middle. So there's the middle part. And let's see, we have 41 and 43 on the next page. So there's 41 and 43, okay? All right, it looks a little bit better in my opinion. Maybe not for you guys, but hopefully that seems better than what it did for the old computer. And now that's all the problems that are there. Okay, so I will do just part D as in dog. So they give me the point 1, 4 and a slope of 1/3. And my book just fell down, so gotta pick it up. Okay, so I throw directly into the point slope form. Y minus y1 equals m times x minus x1. Okay, so y minus 4 equals the slope 1/3, x minus 1, and then just clean it up. And I'll just say parenthetically for the rest of it, they just changed the slope for A, B, and C. So all you do is change this. So for A, B, and C, this is still going to be 4. This is still going to be 1 because they said it's always going to be 1, 4. And the only thing you're changing is the slope. So just plug in to here. Okay, so that's 1/3 x minus 1/3. Add 4 here. Add 4 here. Got to get a common denominator, so I'll multiply by 3 over 3. So plus 4 over 1. So that gives me 1/3 x, let's see, minus 1 plus 12, right? So minus 1 plus 12 is plus 11. So final answer, f of x is 1/3 x plus 11 over 3. And that's about it. Okay, 23. To give you this information, here's a point, here's a line. Okay. Come up with the equation of a line that goes through the point parallel to the given line and perpendicular to the given line. So parallel and perpendicular. And how do you do that? Okay, so it has to go through this point. You might recall parallel lines have the same slope. So what's the slope of this line? Well, -2. So what's the slope of a line parallel to it? -2. So for the first part, I want parallel lines, so I want the slope to be -2. for perpendicular lines, and this is abbreviation for perpendicular and upside down T, perpendicular. Okay, so upside down T is abbreviation for perpendicular, two lines that meet at 90 degrees, but it takes too long to write P-E-R-P-E-N-D-I-C-U-L-A-R sometimes, so we just do this. Okay, so for perpendicular lines, you might recall we want the negative reciprocal, we said. That means flip this and change the sign. So the reciprocal of -2 would be -1/2, and then just make it a positive, so +1/2. Okay, so we're using this point. For a parallel line, use the same slope, -2. For a perpendicular line, use the negative reciprocal, which in this case is 1/2. Okay, so here we go. For parallel, y minus y1 equals m, which is -2, times x minus x1, x minus a -1. And I'll just say, etc. You can finish the rest of that on your own. Okay, so I'm using the point slope form, which is this. Okay, the x1, y1 is -1, 2. So -1 goes there, 2 goes there, slope goes there. And I'll just say, etc. You finish the rest of that. That's for the parallel case. Okay, and then for the perpendicular case, that's an upside down T, which means perpendicular. Okay, so you have the same point. So that's still y minus 2. This is still x minus a -1, but instead you use the slope of 1/2. And then clean it up. So again, I say, etc. Okay. All right, next I'm going to do 19 and 20 for you. They're a little bit unusual. It's sort of a matching problem. Let me show you what they say. Okay, for 19, they have A, B, C, D, E, F, G, H, I, J, 10 different lines. Graph the following lines into sets that are parallel. And then 20, same thing, A through J, there's 10 of them. Group the following lines into sets that are perpendicular. Okay, so what you have to do is first find the slopes of all of these. Okay, so I notice for A, it's a horizontal line, so the slope is 0. And likewise for F, the slope is 0. So it's a horizontal line. So 19A is horizontal, F is horizontal. B, slope is 1. D, slope is 1. C, slope is -1. Right, you just look at the coefficient of x, the number in front. Okay, so I now have A is horizontal, B, m equals 1, C, m equals -1, and D, m equals 1. I have F is horizontal. E, the slope is 2. Oops. Yeah. Okay, G, you have to make it look like y equals mx plus b. So if I subtract x for G, it looks like y equals -x, which means the slope is -1. Okay, H, same thing, I have to isolate. So for H, move the 2x over. If I move 2x over, it says y equals 2x plus 2. Y equals 2x plus 2, which means the slope is 2. Okay, I, for letter I, if I add y and subtract 4. Add y, subtract 4, it'll look like this. X minus 4 equals y, which means the slope is 1. And finally for J, let's see. For J, if I move 2y over and I subtract 1, add 2y, subtract 1, it will look like this. 2y equals 2x minus 1. Divide by 2, divide by 2, divide by 2. Y equals x minus 1/2, which means the slope is 1. Okay, so now I'm going to lose the book, as long as I don't drop it. And now look at this. Okay, so now we're asking for situations where the lines would be parallel. So parallel lines have the same slope. So I just look for the same slope. Well, A and F were both horizontal. which also means slope is 0. All right, so a pairing would be A and F. We're supposed to pair them for the same slope. And then I have C and G, both -1. So CG. E and H both have a slope of 2. So that's EH. See what's happening? We're just looking for the same slope. I and J both have a slope of 1. So I and J are paired. And B and D also have the same slope. So B and D. In fact, I, J, B, and D could have been paired any way that you want. They're all together, but this would be fine also. Okay, so 19, asking for group by parallel lines of the same slope. 20, I do the same thing, but it says perpendicular. All right, so first again, find out all the slopes. Okay, A is horizontal, slope is 0. If this is horizontal, what do you think B is? B is vertical. Okay, X equals a number is vertical. So right now I have for 20, A is horizontal, B is vertical. Okay. Slope is 0. Slope is undefined for vertical lines, right? So let me go ahead and write it, M undefined, that's extra though. Okay, so horizontal line, slope is 0. Vertical line, M, that says M undefined. Slope is undefined. Okay, let's see. C, slope is 2. D, slope is 3. E, slope is 1/3. F, slope is 1. How do we know? It's just a coefficient, the number in front of the X. G, slope is -1. H, slope is -3. Okay, so let me show you all of those. Okay, so C, slope is 2. D, slope is 3. E is 1/3. F is 1. M stands for slope, you might recall. G is slope is -1. H is -3. I and J, you had to do a little bit of work. I got it written down here, but I, okay, so you have to isolate the Y, right? So subtract X, I would minus the X and divide by 3. Okay, so I did it for you here. For I, it looks like this, 3Y equals -X minus 5, divide by 3, divide by 3, divide by 3. It looks like that. Y equals -1/3 X minus 5/3. So the slope is -1/3. And likewise for J, J as in Judy, solve for Y to get the slope. So X plus 2Y equals -1. So subtract X, right? And divide by 2. Subtract X and divide by 2. So let me lose the book. And I just dropped it again. Fun for me. So 2Y equals -X minus 1, divide by 2. Y equals -1/2 X minus 1/2. So the slope is -1/2. That's what we want. Okay, now we're supposed to pair them by which are perpendicular to each other. Okay, now you know that a horizontal and a vertical line are perpendicular, right? One's like that and one's like that. If one's horizontal and one's vertical, they meet at 90 degrees. So A and B. And then after that, you're looking for negative reciprocals. Negative reciprocals like C and J, CJ, 2 and -1/2. Okay, those are negative reciprocals. So they're going to be perpendicular. Okay. E and H, slopes of 1/3 and -3. So if you flip this and change the sign, the reciprocal of 1/3 is 3, right? And then put a negative sign, we'll make it -3. So those are negative reciprocals. And then we have F and G, slopes of -1 and 1, yes. So what do you get when you flip 1 over 1? Well, you still get 1 over 1, then put the minus sign, so -1. And by default, the last ones are D and I. So one is what? Negative 1/3, and the other is 3. And that's what we have for that one. Okay. And another way to think of it is if you multiply the slopes, you get negative 1. So notice if you multiply 2 by negative 1/2, you get negative 1. If you multiply negative 1/3 times 3, you get negative 1. If you multiply negative 1 times 1, you get negative 1, and so on. So the product of the slopes, if you multiply the slopes, you get negative 1 also. Okay, so that's 19 and 20. Okay, so that was that one. Okay, now a different type of problem is 29. So jumping over to 29, if I can find it here. Okay, they give me an x-intercept and a y-intercept. X-intercept of 1, y-intercept of 3. Find the slope-intercept equation of the line that has the given conditions. Okay, x-intercept and y-intercept. Okay. All right, you might recall x-intercept means y equals 0, and y-intercept means x equals 0. Okay, so x-intercept of 1 means you have the point 1, 0. By the way, I graphed it, but you don't have to graph it. You may graph it if it helps you, but it wasn't necessary. Okay, you have the point 1, 0. That's where it touches the x-axis, you might notice. Okay, and y-intercept means x equals 0. And this point is 0, 3. Notice that's where it touches the y-axis. Okay, so I'm pretty sure I had it before, but just a reminder, for y-intercept, you say x equals 0, and for x-intercept, you say y equals 0. And extra, a little bit extra, notice this is the x-axis, right? Everywhere along the x-axis, as I move along, the y value is 0, right? And likewise, if we look at the y-axis, if I go up and down the y-axis, everywhere here, x is 0. Okay, so you have 2 points. So you could work the rest of the problem out like the first one I did, where they were giving you 2 points, right? What was that, problem 3, I think it was? But since I've got this picture, I might as well take advantage of it. I got the b. I have the y-intercept already as 3. So I just figure out the slope. It's going to be negative because it's falling, right? The graph is falling. So if the graph is falling, you know the slope is negative. And from here, it looks like I go right 1 and down 1, 2, 3. So over 1 and down 3, that means the slope is negative 3. Or you can plug into the formula. But if you go rise over the run, right? You run 1 and you fall 3, so the slope is negative 3. So there we go. Y equals negative 3x plus 3. And that's the answer. Okay. All right, 33. See, passes through 4, 3. Okay, once they give you that, that's your x1, y1 that you can plug in. Okay, parallel to blah, 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 blah. All right, so you know parallel means same slope. So I just have to figure out the slope of this by solving for y. Make it look like y equals mx plus b. I'll use that slope. I'll use this point and throw it into the point slope form. Okay, so this is already my x1, y1. Now I've got to figure out the slope. And so here we go. 4, 3, parallel. This is the abbreviation for parallel. You draw 2 parallel lines like railroad tracks. So this is the abbreviation for parallel. Okay, so a little bit of algebra. What did I do? I added 3y and subtracted 2. Okay, so move the 3y over, it becomes positive. Move the 2 over, it becomes negative. So it looks like this. Divide both sides by 3. And this is the equation. So the slope of this line is 2/3. Made it look like y equals mx plus b. Y equals 2/3 x minus 2/3. So the slope is 2/3. So what will be the slope of a line parallel to it? Also 2/3, because parallel lines have the same slope. So I use this slope, and I use this point, throw it into the point slope form, which is y minus y1 equals m times x minus x1. So here we go. x1, y1 are 4, 3. So 4 goes here, 3 goes here. The slope was 2/3, so put 2/3 here. Okay, and I say etc. Stop from there. You can finish the rest of it. By the way, of course, I hope you got the idea, but I get to say etc., but you don't get to say etc. I mean, on a quiz or test, you don't get to say etc. You have to finish it. But I stop after a while, hoping you can realize, okay, you can finish the rest of that algebra, right? Multiply this out, add 3, blah, 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 right? Okay, so that's that one. Now let me show you a perpendicular question. That would be 35. Okay, so 35. Reminder, these problems are right off the homework. Every one I'm doing is one less you're doing. Okay, perpendicular to blah, blah, blah at the point 1, 1. So again, you have your x1, y1. Just use x1, y1. And now I have to figure out the slope and perpendicular. So y equals 2 minus x. Okay, perpendicular. This upside down t again means perpendicular to y equals 2 minus x at 1, 1. So m1 means the slope of the given line. So the slope here is -1. The coefficient of x is -1. So for perpendicular, I want negative reciprocal. So I flip it and change the sign. What's the reciprocal of -1? Well, it's still -1. And change the sign, it's 1. So I use this point and this slope. So y minus 1 equals 1 times x minus 1. And a little bit of simple algebra gives me y equals x. Okay, because if you have this, you can ignore the 1, right? If it's 1 times this, it's just this. So notice if I ignore the 1, because 1 times x minus 1 is just x minus 1. And notice what happens if I add 1 to both sides. If I go plus 1, they're all gone. So it's just y equals x. So the final answer is y equals x. Okay. All right. And a couple more problems, and then I'm just about done, I think. 39. Show you that one. The function defined by v of t equals -32t, v stands for velocity, t is time, describes the velocity of a rock t seconds after it has been dropped from the top of a 784-foot high building. Sketch the graph of v, determine the velocity of the rock when it hits the ground 7 seconds after it has been dropped. Okay, that's not really that big a deal. Okay, I'm essentially graphing y equals -32t. Okay, so what's the slope? -32. And the y-intercept is 0, so it should touch the origin, which makes sense. At time 0, you haven't dropped it, so the velocity is 0. Okay, but this graph is only going to be in the 4th quadrant, as it turns out. So I drew the graph like this. Slope is -32t. You would ordinarily think it's going like this, but for experiments like this, like in the science lab, usually you would start with t being 0. So I don't have any graph over here. Okay, so I'm only going this way, positive, and I changed the scale. Okay, so I decided to call this -32, -64, and so on. So the graph goes like this. Plug in 7. Plug in 7. -32 times 7 is a -224. Okay, so the graph goes something like that. And they asked me to plug in 7. Okay, so I plugged in 7, -224. Okay, so -224, and it looks like I have feet per second. So that's it for that one, -224 feet per second. All right, then 43, and I'll be done. And I'm done with what I was going to go over. So let me show you 43. Unfortunately, I'm saying that's the last problem, but it's not short. It'll take a while to develop it a little bit. Okay. It says a new car costs $28,000. After 3 years, its value is $16,000 by depreciation, right? So you know that cars in general, that's not true for all cars. Some cars actually appreciate, they go up in value, but most cars depreciate as time goes by, they wear out, they're not as good, so they're worth less. The depreciation of the car is assumed to be linear. Find an equation that expresses the value of the car in terms of age. What is the value, blah, blah, blah. Okay, so the hardest part is to do A. Once we find A, B, and C will follow along pretty easily. So essentially, I'm changing this problem into something like problem number 3, where I have 2 points. Okay, so at time 0, at the beginning of the experiment, the car is worth $28,000. So that's 1 point, 0 and 28,000. And the second point is 316,000. Right? So here's the way that we're going to set it up. They want V as a function of T. Okay? Think of it as Y equals a function of X. So T is like the X coordinate. V is like the Y coordinate. How do you know? Because they say so. They want time as a function of value. Okay, so time, value, new 28,000. So as a point, I put 0, 28,000. And by the way, in this case, I decided not to put the comma because there's a comma here, right? If I put another comma, you might get mixed up. So how come there's a comma here and a comma here? So I put 28,000 without the comma. I think it's easier that way. So that's 1 point on the graph. And then after 3 years, it says 16,000. So notice I have 3, 16,000. And 316, again, notice I don't put comma. It's just 3, 16,000. So it's like X, Y, except it's T and V, time, value. Okay, value is a function of time. So now I work the rest of the problem out just like, question 3, the first one I did. Okay, so let me get that for you. So it's the same thing, only they give us harder numbers. So find the slope. So y2 minus y1 divided by x2 minus x1, right? So 16,000 minus 28,000 divided by 3 minus nothing. That's negative 12,000 over 3, which is negative 4,000. So the slope is negative 4,000. And the significance of that negative 4,000 is the car depreciates $4,000 a year. So for this particular car, it goes down in value by about $4,000 every year. And that makes sense. Let's see. So 28,000 new, right? So if it goes down by 4,000, after 1 year, that'll be 24,000, right? After another year, it'd be 20,000. And then after the third year, 16,000. So yes, it does seem to match. Okay, now I throw it into the point slope form. You're allowed to pick either point. I think I'll pick the point that has a 0 because I like plugging in 0. So this is my x1, y1. So y minus y1, 28,000, equals m, negative 4,000, parentheses x minus x1, x minus nothing. I like subtracting nothing. So this means it's just negative 4,000x, add 28,000. So here is the equation. Y equals negative 4,000x plus 28,000. Okay, that's y and x, but we have to change it to t and v. So write it as a function like this. So just letting x be t and y be v, write it like this. So the best final answer for A is v of t as a function. V of t is negative 4,000t plus 28,000. Notice what happens when you plug in 0. If you plug in 0, that's gone. 28,000. And that fits the original statement that at the start, beginning of the experiment, time equals 0, the car was worth 28,000. Okay. Part B, what is the value after 5 years? I just plug in 5. So plug in 5 right here. V of 5 is the way we would say it. So negative 4,000 times 5 plus 28,000. Punch it in your machine, and you get $8,000. And finally, C. when will the car have no value? Okay, no value means the value is 0. So I set the left-hand side to be 0. 0 equals negative 4,000t plus 28,000. Solve that. Add 4,000, divide by 4,000, t equals 7 years. So they're saying after 7 years, it's practically worthless for this particular car. Okay, mind you, this is just a model. We know this is not 100% true. I mean, I've got a car that lasted 7 years, 10 years. Okay, it's not really worthless per se, but you won't be able to sell it for very much, I suppose is the way to say it. All right, folks, that's it for today. So let me stop the share and turn off the